Well, hello! How's it going? I wanted to show you guys some things just on this homework that we had. So this here is a paper that you have, and it's just function notation practice. So this, based on what we were doing in class, should be pretty straightforward. And the nice thing is you have an answer key on the back right here, although turns out I'm not perfect. That negative 5.5 should actually say 18.5. And that negative 3 should just be a positive 3. So if you've already started working on this, didn't catch those mistakes, I apologize. First thing you want to do is fix that, finish part 1, and then we're actually just going to use this video to go over part 2. And these are some solving equations problems that I noticed on the test some of us were kind of shaky on. So not all of us, but many of us could probably use a refresher on this. So bear with me, we're going to go over this example. This will be a similar example that you can do by yourself, and then we'll go ahead and get that one started. Something I haven't really talked a ton about in class, just because we've kind of been moving a little fast. Why do we solve equations in the order that we do? And it's kind of connected to something that you learned in middle school. Some of you guys should remember PEMDAS, right? Where we basically start with parentheses. If we don't have those, we'll move to exponents. If we don't have those, we'll solve anything that has multiplying or dividing, right? And we go from left to right, just depending on what comes first. Knock that out, and then do adding or subtracting at the end. So this is a rule that we use when we know all the numbers, right? So if you just had something like this, but instead of a W, we had like 10, right? Where would you start? You'd kind of move through this. Well, something that most of us probably didn't learn in middle school is that this P, which stands for parentheses, could actually be replaced with a G, which stands for grouping, okay? And so grouping symbols could be parentheses, they could be brackets, right? But they could also be just a really long division problem where you put an expression up top and then you have a number on the bottom to divide by. So like basically you're grouping the top away from the bottom. And if you had a bunch of numbers, you would solve what's on top first, and then the last step would be to divide, because this is by itself, right? So normally, you'd work in this order if you knew all the numbers, right? So just a long order of operations problem, we just work from grouping to exponents and kind of work our way down. Well, when you're working with variables and you're trying to solve for one of the missing variables, you actually go in reverse order. So you do the easiest things first, so you look if there's any adding or subtracting we can get rid of. Then you unpack the multiplying and dividing, then you unpack the exponents, then at the end you unpack the groups. So if you look at a problem like this, and we'll kind of zoom in. So it says solve for x, and we have x plus 9 on top. So this is actually a group, and we're not going to unpack that until the very end. This negative 8 that we're dividing by is actually the first thing we're going to get rid of, because you have kind of working up backwards, right? So we're looking for adding and subtracting first, which we don't see in this problem. Then we'd look at multiplying and dividing, right? Then we'd look for exponents, then we'd look for groups, which we have. We just haven't seen this type of group before where it's using a division symbol to group. So we're just going to get rid of this negative 8 through the inverse operation of multiplying, right? So x plus 9 is left alone. We're just trying to get rid of that dividing negative 8. Anything we do to one side, we do to the other. Negative 4 times negative 8 is positive 32. And now we're going to bring that group down, x plus 9, right? So these are connected. We're not doing them. We're not going to do anything with this until the second step. Now that we have this negative 8 gone, this is just a basic 7th grade equation or 6th grade equation. X plus 9 makes 32. We want to get rid of the add 9. X comes down. And then 32 take away 9 is 23. So the big idea here, like that you need to know, is just if you see numbers on top, they're kind of connected. We're not going to worry about that until the end. Instead, we're going to get rid of this negative 8 that's by itself, and we're just going to use the inverse operation. Okay, so it's just something we'll get used to and we'll see more practice on as we move along. So what I'd like you to do is take this work here and see if you could work this one out. So you're just thinking about, would you get rid of the subtract 3 first or the divide 5, right? Think about which one is separate, kind of think about this as a group and just save it for the end. If we look down here, this problem's a little different. We can't do anything with these two sides of the equation until we get rid of these parentheses. And anytime you see a number that's attached to a set of parentheses, you're looking to distribute that number to anything that's inside of the parentheses. So we have an x and we have an add 30. So that 0.5 is going to get multiplied by both of those things. If I do 0.5 times x, I just get 0.5x. If I get 0.5 times add 30, right, I'm going to add whatever 0.5 times 30 is. So the add stays the same, 0.5 gets multiplied by 30. If you were to punch that in your calculator, you would get 15, because it's just half 30. Equals comes down, and I should be doing this. I really like the kids who've just been organizing it where they kind of draw the line down. So I'm going to start doing that myself. On the right side, we have a 6 plus 0.25x minus 4. That's in parentheses. So that 6 is just kind of on its own, right? That 0.25 is actually attached to this group here. And inside of this group, there's an x and a minus 4. So there's two terms. And that 0.25 is going to describe or get distributed to both of those terms. So 0.25 times x, I'm going to bring my plus sign down. 0.25 times x is just 0.25x. 0.25 times minus 4, if I were to do that in my calculator, which I can go off to the side and do, so I'll just give you a second if you want to look at that. It's 1, right? So 0.25 times 4, you can almost think of it like money, right? And if you notice, there's a subtract here, and we just bring that 1 subtract sign down, okay? So we have a 6 plus 0.25x minus 1. Now, something you may just want to be looking at is on the left side, we have two terms, a variable and a constant. On the right, we actually have 3. So we're going to try to make that smaller before we do any math, or before we start working backwards to solve for x. So you're going to look at that 6, right? We can't add 0.25x to the 6 because we have variables, we have constants, they're not the same. But if I continue, and I'm wondering, can I subtract 1? Well, I can't subtract 1 from the 0.25x because they're different, but I can subtract 1 from the 6. So before I start solving, I'm going to go ahead and take 6 minus 1, and that gives me 5. And then that 0.25x that I'm adding is just going to come straight down. So if I were to take the two sides of my equation, now you'll notice I just have 2 terms on the left, 2 on the right, so it looks a lot like an 8th grade equation. And at this point, all you're going to do is just try to get x by itself, okay? I see that this is almost like a 50 cents. I could add a 0 if I wanted to. On the right, I have 25 cents. My rule is I just like to go to the side where I have more x's. So I eventually want to get my x by itself on that side because I have more. So I can take the 25x away and do the same over here, right? So to get rid of this, I just do the opposite. Over here, I'm left with 0.25x plus 15 makes 5. And at this point, what I'd like to see is just, could you take what is basically a 7th grade equation and get x by itself? Okay, so I'm going to leave this one undone. You just need to finish this, see if this can make a little bit more sense, and I promise you we'll get more practice on this just kind of over the next couple weeks so we can get solid on it. Thanks for taking the time to watch this. I will see you in class, y'all.